All right. For the distance problems for today, I need your attention up here, please. So again, Friday we went through mixture and work problems. Those are two applications that deal with setting up rational equations. Distance problems also can deal with setting up rational equations. It doesn't mean the equation you set up has to be a rational equation, but it could be. So if you look at what is written above example 1, this is where a rational equation could come into play. So a formula that I'm sure you've seen before, formula that relates distance, rate, and time can be used to solve rational equations. The most common use is D equals RT. So that is the distance formula relating rate and time. So for example, if you wanted to calculate how far you drove and you were going 60 miles an hour for 2 hours, you would just multiply 60 by 2. So your rate multiplied by your time to get your distance. However, you could also use either of these two variations of that formula. So if you divided the distance formula, if you divided both sides by t to solve for the rate, you would get this formula, that rate is distance divided by time. If you divided both sides by the rate to solve for time, you would get time equals distance divided by the rate. So when you have to use either of these two forms of that distance formula, you could then potentially get a rational equation because you can see you'd have distance over time, you'd have a fraction within there. So if we look at example 1, not all of these problems would be set up the exact same way. So I'm going to explain things to look for so you know how to set these up. It says Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour. It takes Sandra 3 hours to travel 10 miles round trip. Assuming that Sandra rowed at a constant rate of speed, determine the rate of the current. Okay, so I'm going to write down, because we have what we're looking for. Determine the rate of the current. So our answer should be in miles per hour, how fast is the current going on this lake? So what I'm going to write down here, since I'm looking for the rate of the current, I'm just going to define a variable for the rate of the current. I'm just going to call it C for current. And then we should be able to pick out in this problem, again, we're dealing with distance, rate, and time. And it does give us all three pieces of that formula. So it gives us actually two different rates. If we go back and reread, we have Sandra's rate for rowing the canoe. Sandra's rate, if the water is still, is 6 miles per hour. So I'm going to write down, Sandra's rate equals 6 miles per hour, because we have two different rates technically, Sandra's rate and the rate of the current. But then we have that it takes Sandra 3 hours to travel 10 miles round trip. So we have a total amount of time is 3 hours. And then we also have a total distance of 10 miles. So those are kind of our three pieces, our rates, our time, and our distance. So here's where you have to figure out which of these three variations of the distance formula you'll be using. And here's how you can determine that. Look at the totals that you're given. So we're given two different totals. We have a total time, we have a total distance. And realize Sandra is, the 10 miles is round trip. So she's going one way and then she's coming back. And if you kind of picture this on a lake, assuming the current is traveling in the same direction the entire time, one way she's traveling with the current, so it might help push her along. The other way she's going to be fighting the current. She's going against the current. So she's going there, she's going back. Round trip, it's 10 miles. So in that total time of 3 hours, is it going to take her the same amount of time both ways? Or let me ask you this. In the total distance of 10 miles, is she going the same distance both ways? I see some nods. So could I say if it's 10 miles round trip, that if she goes 5 miles one way, 5 miles back, does that make sense? She went the same distance both ways. Would it make sense if I said with the current it's taking her an hour and a half, so half of 3 hours, and then against the current it takes her the same amount of time? Does that make sense? I also still see some nods. I see some no's. Are you gonna go the same speed when a current is helping you as it will be when it's pushing against you? No. So if the current's helping you, you're going to go faster, right? And if you're going against the current, it's going to slow you down. So it's taking her 3 hours. It does not make sense, though, to say it took her the same amount of time both directions, because one way the current's helping push her, it's going to be a little quicker. One way she's fighting the current. It does make sense, though, to say if she went 10 miles round trip, she went 5 miles each way. Her distance both ways was the same. Her time both ways, though, would be different. Okay, so now using that information, what I'm going to do is I'm going to set up an equation where all of my expressions represent time. So I'm going to be using this formula, that time is equal to distance divided by rate. So I'm going to use the time as my official total. So when I set up an equation, my end, what it's going to be equal to, it's going to be equal to 3 hours, the total time. So what I need to come up with then are two expressions in terms of time. I'm going to write an expression for the time with the current, where the current is helping her. And then I'm going to set up an expression of her time against the current. Okay, and we know the total time already is 3. So starting out with time with the current. So I know time is represented as distance divided by rate. So the amount or the distance she traveled with the current would be half of her total distance. So her numerator here would be 5. She went 5 miles with the current. The rate then, if the current is helping her, the rate would be Sandra's rate added to the rate of the current. So the rate would be 6 plus C. So her rate plus whatever speed the current is traveling at. It's helping her go faster. When she's going against the current, this is still distance divided by her rate. The distance is still 5. She had to travel 5 miles back. But the rate now, if she's fighting the current, it's slowing her down. So it would be Sandra's rate of 6 minus the rate of the current. Okay, so one of the denominators is the two rates added together. It's helping her go faster. The other denominator, it's slowing her down. So you're subtracting the speed of the current. It's fighting against her. Okay? Questions on how I came up with these? So now to set up an equation, the equation is going to be that the time with the current plus the time against the current should equal the total time, which was 3 hours. So I would have 5 over 6 plus C plus 5 over 6 minus C should equal 3, should equal 3 hours. That's the equation that we would need to solve for C. Okay, so this is a rational equation. We have fractions, there's variables in the denominator. So now reviewing how we solve a rational equation, what do we need to do first in order to solve this? We need a least common denominator. If it helps, you can change that 3 into 3 over 1 so that you have everything as a fraction. Okay, you don't have to do that, but if that helps you see everything as a fraction, you can do that. What would the least common denominator be? If it also helps, you could put parentheses around these. Those are each quantities. Not just 6c. That'd be part of it. Yeah, and 6 minus c. Yep, so these are different. So if I wanted these to be the same, I would have to multiply this one by 6 minus c, this one by 6 plus c, and then I'd have to multiply this one by both since I don't have a denominator. So this is the least common denominator. So then remembering what we did last week, I have to multiply all of my terms by this. So I'm actually going to write this out. I have 5 over 6 plus c, and that's going to be multiplied by my LCD, 6 plus c, 6 minus c. It helps, you can put that over 1. And then plus 5 over 6 minus c times 6 plus c, 6 minus c over 1 equals 3 over 1 times the LCD. Okay, and we should see all of our denominators cancel out by doing this. So in my first fraction, the 6 plus c's will cancel. So I'm left with 5 times the quantity 6 minus c. You could distribute right away if you wanted to. I'll do that in the next step. And then plus, in the second fraction, the 6 minus c's cancel. So I'm left with 5 times 6 plus c. And then on the right side, I didn't have a denominator to begin with, so nothing cancels out. I just have 3 times 6 plus c times 6 minus c. And now I have to simplify this equation so that I can solve for c. So on the left side, I'll distribute. So I'll end up with 30 minus 5c plus 30 plus 5c. And then on the right side, before I distribute 3, I'm going to FOIL these here. So first terms, I'm going to leave the 3 outside for right now. First term, 6 times 6 is 36. My outside and inside terms, I would have minus 6c and then plus 6c. So those are going to end up canceling out. So if it helps you, you can actually write that out. But you'd have minus 6c plus 6c. Those are going to cancel. And then my last terms would be c times negative c. So I'd have minus c squared. Okay, so I still have some simplifying that I can do. On the left side, the minus 5c plus 5c, those terms end up canceling. And then I could combine the 30 plus 30, so I have 60. And then I can distribute 3 on the right side. 3 times 36 is 108. So I have 108 minus 3c squared. Okay, and I still need to solve for c. What would I do from here to solve for c? Subtract 108. So 60 minus 108 is negative 48. And I still have a negative 3c squared. Then what? Divide by negative 3, get that c squared alone. Negative 48 divided by negative 3 is positive 16. So that equals c squared. Solve for c. Square root each side. Now remember, you do get two answers when you take the square root. I would have c equals positive 4 or c equals negative 4. Do both of these answers make sense? No. Which one is the answer? The positive. You can't have a negative speed. Okay, so negative 4 is a solution to the equation. It doesn't make sense for the actual problem. So we get 4. Now you could, and you should probably check this into the original equation you came up with, make sure it actually works out. So I'm just going to do this, and then you could check on your calculator too. But if you checked this, replacing the c's with 4's, you'd have 5 over 6 plus 4 is 10. And then plus 5 over 6 minus 4 is 2. Does that actually equal 3? 5 over 10 is 1/2. And if you add 1/2 and 5 halves, that's 6 halves, which is 3. Okay, so just double checking that you did solve the equation you came up with correctly. So our answer is 4. I wanted to know the rate of the current, so I'm going to say the rate of the current is 4 miles per hour. So the current is moving at 4 miles per hour. Adler? So because what I did is I looked at what I had totals of. So because you're looking for a rate, you're probably not going to use this one because you don't. You have her rate already. You're looking for the rate of the current. So if you're looking for a rate, you're probably not going to use this one. We had a total time and a total distance. So that led me to believe we were either using the one that's equal to t or equal to d. But then we talked about in terms of splitting it, we could, with the time with the current, the time against the current, or her traveling with the current and against the current, we know that the two distances each way would be the same, the two times would not be. So then we used the time as our actual total. So part of it is kind of figuring out what you have. I'd say for most examples, it's probably going to be set up this way, but it's not all the time. So you'll have a chance to work through some to kind of figure out how to set it up. All right, any other questions on this first example? We're going to go through another one. Okay, so then example 2 says the speed of the wind is 20 miles per hour if it takes a plane 7 hours to fly 2,368 miles round trip. Determine the plane's speed in still air. All right, so similar to the last example, I'm going to start with we're trying to determine the plane's speed, or the speed is the rate. So I'm going to put here plane's speed. I'm just going to call that P. That's what I'm looking for. So I'm looking for a rate, again, like the last example. I am also given, if I go back and just lay out what I'm given the speed of the wind. So I'm going to put here wind speed is 20 miles per hour. So that's the rate information that I'm given. I'm also given a total time. It takes the plane 7 hours to fly round trip. So total time is 7 hours. And then I'm also given the total distance of 2,368 miles round trip. Okay, so like I was just saying, based on the previous example, not all of them have to be set up that way. A lot of them will be set up that way. This one has a very similar setup to it because you're looking for a rate of the plane and looking at the two totals that you're given. Again, we can split the distance in half and say that each way, if it went 2,368 miles round trip, if we divide that by 2, we know that it would have gone 1,184 miles each way. But one way the plane is traveling with the wind is helping push the plane. The other way, this is assuming the wind is going in the same direction the whole time. The other way, the plane is fighting the wind, fighting against it. The wind is going to slow the plane down. So each way we can't say will take the same amount of time. So we're going to set this one up similar to the last one. We're going to have our equation in terms of time, using the time equals distance divided by rate. So I'm going to set up an expression for the time with the wind, where the wind is helping the plane, and then the time against the wind. All right, so with the wind, distance divided by the rate. So we know each way the plane traveled 1,184 miles. So the distance on top is 1,184. The rate on the bottom, if it's with the wind is helping, it would be the plane speed plus the wind speed. So P plus 20. For the time against the wind, again, it's distance over rate. The distance is the same, 1,184. The rate, though, now the wind is slowing the plane down, so it would be the plane speed minus the wind speed, so P minus 20. And we know the total time it took is 7 hours. That was given. So our equation would be the time with the wind plus the time against the wind should equal 7. So we would have 1,184 over P plus 20 plus 1,184 over P minus 20 should equal 7. And again, if you want to put 7 over 1, that's fine. Okay, so questions on coming up with the equation. Okay, so then from here, just like we did in the previous example, we need a least common denominator. What would our least common denominator be? Yeah. Okay, so I have 1,184 over P plus 20 multiplied by the LCD plus 1,184 over P minus 20 multiplied by the LCD equals 7 over 1 multiplied by the LCD. Okay, so then for the first fraction, the P plus 20s cancel out. So you have 1,184 times the quantity P minus 20. For the second fraction, the P minus 20s cancel. So you have 1,184 times P plus 20. And that'll equal, again, nothing cancels on the right side. It wasn't a fraction to begin with. So 7 times p plus 20 times p minus 20. And then simplify. So on the left side, I'll distribute. So I'll have 1,184p minus 1,184 times 20 is 23,680. Then plus 1,184p plus 1,184 times 20, so plus 23,680 will equal, I'm going to keep the 7 outside and then FOIL the p plus 20, p minus 20. So first terms, I'll have p times p, so p squared. The middle terms, again, will cancel because you have p times a negative 20, so negative 20p plus 20p, those will cancel out. And then I have 20 times negative 20, so that's minus 400. And I'm going to take one more step to simplify. On the left side, I can combine like terms. So the 23,680s will cancel out since one of them is negative, one's positive. And the 1184p's I can add together. That'll give us 2,368p equals, and on the right side I'm going to distribute the 7. So 7p squared minus 2,800. Okay, so up until there, the process we were using is the same. But now to actually solve this equation for p, we cannot solve it the same way we solved the previous example. It's still a quadratic equation because we have p squared, but we have this other p on this side. So what would we have to do here to solve this equation for p? We can't solve this one by square rooting each side at some point. Divide by p? Well, if I divide by p, though, I have to divide everything, including this, which means I'm still going to have a fraction here then. Well, I mean, if you divided everything by 7, but this you can't divide by 7. Yes, get it equal to 0. So I'm going to subtract. I like to keep the term that's squared positive. So I'm going to subtract this term. So, and I'm going to flip it around so I have it equal to 0 at the end. So I'd have 7p squared minus 2,368p minus 2,800 equals 0. Once it's equal to 0, how can we solve this? You could factor it. Factoring would not be my choice. So how else could we factor this? Or how else could we solve it? This isn't the answer. Quadratic formula, yes. Okay, so I'm going to put that off to the side. It'll be p equals not x because our variable is p. So it's going to be opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so our opposite of b would be positive 2368 plus or minus the square root of. This I'm just going to calculate right away to get a value to put in here. So on my calculator, I'm going to do my b value squared. So in parentheses, negative 2368 squared. And I'll hit enter. And then minus, just leave that number in there, minus 4 times my A value is 7 times my C value is negative 2,800. So I get 5,685,824 in the square root. And that's all over 2 times A would be 2 times 7, which is 14. Okay, and remember you do get 2 answers, so I actually am going to get the decimals for these. So for the first one, I would take 2368 and add the square root of 5,685,824. Hit enter, and then divide by 14. And if I round it to 2 decimal places, I'll do 339.46. Okay, but do remember, I just don't want you to forget, you're only going to have one answer to the question. This equation, though, does give you 2 answers. So your second answer would be if you took 2368 and you subtracted the square root of 5,685,824. Hit enter, then divide by 14. But this one is negative 1.18. Okay, plane can't travel a negative speed, also 1.18 miles per hour. That's really, really slow for a plane. That'd be kind of scary. So this one doesn't make sense. So this would be our answer. Okay, so the plane's speed is, I'm going to say about, this isn't an exact answer, we rounded it, is about 339.46 miles per hour. All right, so depending on the setup, you might be left with an equation that's a little simpler to solve, like the first example, or maybe one that requires factoring or quadratic formula to solve, like the second one. This one was just more messy, especially with the values we had to use. They were pretty large. But application problems don't always come out to be nice, exact answers either.